All right, thank you everybody for joining. We're really excited to do this webinar and show you our presentation. A few rules before we get started here. One is that we will be recording this webinar, and we do intend to send out the recording afterwards. And then the other one is that we do want to take questions toward the end of the presentation. If you have any questions, please feel free to submit those in real time as we're talking via the interface in GoToWebinar, and we'll address those at the end. And although it may be obvious from the question, if you do want either me or Louis to respond, just include that in the body of the question so we know which one should be addressing and giving you the answer. Great, well, thanks very much. This is what we're going to be talking about today. It's divided into two parts. The first one is going to be me, and I am the visualization expert. And we'll be just talking about how KeyLines, our product, can be applied to cybersecurity solutions, talking about what the benefit is of looking at data in a connected fashion when you are trying to solve cybersecurity problems, how to expand beyond static visualizations of the data that you have collected, the various techniques that you can use both from a detection, investigative aspect of cybersecurity. So that's both trying to prevent attacks, determine that attacks are happening, and then forensics to discover what happened after an attack. And then we'll just talk more generically about visualization and analysis and how those capabilities will really improve a cybersecurity scenario. And then after about 20 minutes, I'll hand that over to Louis, and he'll get started by talking about his application and how he used KeyLines to help build a cybersecurity application and the benefits he found from using KeyLines, and also talk a bit more about his product and the solution that it provides in the cybersecurity frame. So the first thing is that we are going to be talking about KeyLines today. For those of you that aren't familiar with KeyLines, it is an SDK that many customers use across a wide variety of domains to do visualization and analytics in a web-based fashion. So it's a toolkit for building applications and presenting connected data sets and visualizations of those data sets to end users of the web applications. And you can see that it works across a wide variety of web browsers, across a wide variety of platforms, including mobile platforms. It can be fully customized to your environment. It's because it's a JavaScript HTML5 application, it's very easy to deploy and interface with regardless of the type of data, the structure of the data that you are collecting that you want to visualize. Very maintainable, and also has a number of very unique features that are applicable to cybersecurity among other domains. So in addition to cybersecurity, KeyLines is used across a wide variety of domains. Well, I'm not going to go through all of them today. We're just focusing on one, but I did want to just touch on some of the other scenarios where our customers have found good benefit in using KeyLines inside of their applications. So just to walk through these and just spend less than a minute on each one, the intelligence world, where you're looking at connections, in this case perhaps between gang members, between different tribal members of intelligence or of groups in various areas where we're trying to understand the social connections and social networks. Compliance is looking at legal compliance with various regulations and looking at how those how the operations of a business are connected to one another and how communications may comply or not comply with legal regulations, and looking at those connections can be very critical. Law enforcement is a big user of KeyLines, looking at various types of connected data, including phone call data, including crime data, and looking at those connections and trying to derive different patterns from them to help fight crime. Anti-fraud is one of the big areas where KeyLines is being used, looking at various types of transactional data that can be credit card transactions, insurance claims, things like that, and trying to match patterns to determine which patterns are the normal course of business, say in the insurance industry, which claims are normal claims as a result of loss, and which ones might be fraudulent and worthy of further investigation. Those types of patterns become very apparent when they're visualized. The business intelligence world, looking at perhaps competitive information, perhaps looking at sales, marketing data and how that's all connected, looking at your customers, what those customers are doing, perhaps in an e-commerce world, what pages they're hitting, where they're going to next, those sorts of things to try to better streamline your business process. And then IT management, which fits in with cybersecurity, but looking at how various pieces of an IT infrastructure are all connected to one another to identify choke points, to identify high-risk items in the network, and to identify things like which applications are hosted on which servers and have the impact across a broad array of users of my network. So when it comes down to cybersecurity, the key is data, as it always has been. And the data can be used in a variety of different ways. The advantage that you have in defending against cybersecurity attacks as opposed to the attackers themselves is that you have access to all of the data about what's going on in your network, and being able to take good advantage of that data and being able to use it to determine, as I mentioned at the beginning, what can be happening during an attack, forensics, what happened after an attack, so in order to be able to prevent it in the future. Presenting that data happens in a number of different ways, and there's already a bunch of different tools that can take advantage of that data to present that to an end user who's making decisions based on it. And these are just a few example screenshots, and there's a couple of points that I want to make based on this. The first one is that we are not claiming, I don't think anybody would claim, that KeyLines is the one component that is going to be the solution to all of cybersecurity. It is merely another window into large volumes of data and large volumes of connected data to be able to draw additional inferences about what's going on in a interactive fashion. So these are examples of static dashboards looking from various cybersecurity tools that exist today, but there are limitations to the dashboard-based approach. It gives you a static view of what's going on at any one point in your network. It does not allow for users to explore through their data sets or dive deeper into the areas where they want to better understand subsets of that detail. And so there are limitations to the dashboard view, and that's where we think KeyLines has a huge advantage, because it is an interactive, dynamic approach to looking at large volumes of connected data. And these are what typical network charts look like. And this is sort of the mainstay of an IT analyst who's interested in cybersecurity, looking at network elements, how they're all connected, where firewalls sit, which network elements are on which sides of the DMZ, and things like that. But again, these types of charts, while they're very certainly understandable, they don't provide that interactive experience of being able to dive down and look at the details of the areas that are of interest, while maintaining the context of the areas that aren't. They're very static views. They're very manually created and manually laid out. So what I'm going to present here is just a few screenshots of KeyLines and how it can be used in scenarios like this. We talked a little bit about protection. Some key aspects of protection against cybersecurity attacks are understanding which elements are at risk. And by using KeyLines to identify that, perhaps by using some of our social network analysis centrality scores to identify items that have high betweenness, large volumes of the network, have data flowing across specific network elements, for example, that can be a very powerful way of visualizing that data, and our layouts can help understand of those important items, how are they organized throughout the rest of the network. Another aspect of detection is looking at patterns and trying to match those patterns to things that stand out suspiciously. What we're looking at here is some example of some botnet traffic, and we've color-coded the links and used the width of the link to indicate the type and the amount of traffic flowing between various IP addresses, both on the network on the left and across multiple networks on the right. And you can easily see connections between those items and the various IP addresses that perhaps some suspicious traffic is flowing across by looking at how they're all connected. The investigation is one of the more interesting ones. Looking at traffic after you know that an attack has happened, it helps you identify the size and the scope of that attack. Looking at where it may have come from, which parts of your network it may have touched, and what are the possible vulnerabilities that are exposed as a result. What we're looking at right now is a screenshot of a whole bunch of different types of network traffic that you see, and most of that is benign, innocuous. That's normal traffic that you would see on an everyday basis. Those starburst patterns with 1, 2, 3, or 4 elements associated with them, that's the kind of thing that you would expect to see with various IP addresses sending data, using applications, drawing data from various servers and things like that. What you don't expect to see is that spot in the middle, where you have a large number of what should be disconnected elements having things in common, connected across common various IP addresses or various devices or things like that. So let's go into a bit more detail here. If we zoom in on one of those areas, we see, for example, one specific user who's touching servers across a wide different variety of servers on my network. Most users don't have to have that kind of capability. In fact, most users should be prevented from having that kind of access. So that's an area that stands out very visually when you take a look at this kind of data in a node entity link format. And then if I zoom in even further on that, we've blended out the actual data because this is real customer data and don't want to expose any of that. But you can see that we've done a couple of things to really help identify. We've used the glyphs on nodes to help show to the user right there on the surface of the chart, in this case, where that user happens to be based. We were using color coding on the nodes to indicate these may be suspicious, they may be known infected, they may be known good IP addresses, for example, and things like that. We've used the color and the width of the link to indicate various things about the traffic that we may want to present to our end users. And then the other piece that I'm going to talk about before I jump out and just start showing you some examples here is about dynamic networks. So back in the dashboard slide that I was showing you, we were looking at data in a static form as it stands at this moment. And while that's certainly useful, especially when you're in the midst of things and you just want to understand what's going on right now, there's often a huge benefit to be gained to look at patterns over time in both network traffic, in network attached devices and that sort of thing. What happened, what is happening, and how did those things change? So recently, as KeyLines, a feature that we've added to KeyLines, an important part just in the last 2 months, has been the time bar, an ability to look at various connected data and the pattern that you see in that data over time. So what I'm going to do here is just jump out and spend a couple minutes showing you some examples. So the first one I'm going to show you is just talk about the limitations in how much you really do want to present at any one point. So here is an example where it doesn't always make sense to see every single data element in your data set connected in a link diagram all at the same time. Oftentimes when you bring in large volumes of data, you get charts that look like this, and there's not much benefit to trying to visualize or inspect. This isn't even that large of a chart, 5,000 nodes and 5,000 links, but you can see everything's connected to everything else, as you would expect it would be in IP traffic, and it's not really relevant to try to present that to an end user. So some of the key aspects when you are trying to create useful visualizations for cybersecurity type users are the ability to look at data not just in singular form, but in aggregate. And that's one of the features that we have in KeyLines, is the ability to combine nodes and look at how those combinations are connected. So you may want to, for example, instead of looking at individual data elements, look at groups of nodes and how they're all connected. And then you may want to group those nodes together to take a very summarized view. But then your user does need to drill down and look at the individual data elements from various categories so that they can maintain the context of all of the data that you're inspecting, but look at the details of the areas that are the most interest to them. Here's another chart where we might be suffering from a bit too much data. This is social network data where everybody's connected to everybody else. But instead of just grouping or filtering, what we actually want to do is to allow the user to figure out by which metrics they want to do that filtering and sizing. So here we're going to drag the slider bar up to limit the amount that we're visualizing based only on those items that are very highly connected. So we may not care about the items on our chart that aren't connected to one another. And then when you get down to a more manageable volume, the user has a better sense of what it is that they're looking at. We can also size based on any sort of metric that we want so that the larger nodes stand out. The user can better understand which ones those are. And then the layouts can really help organize the data around the areas that we're most interested in. I wanted to show how KeyLines, one of the things I mentioned is that it's not going to be the only visualization component inside a solution. So we can work alongside many other visualization solutions. In this case, we're looking at a map provided by Leaflet.js, an open source mapping component. And we're using our time bar to look at patterns of traffic across time, trying to indicate and better understand where we might see spikes in activity. This is botnet traffic, but we not only want to answer the when, but also the where. So we may want to look at how those things are changing over time, and in fact, possibly even animate those. So we can watch how this network traffic moved from Eastern Europe to Western Europe as the attack progressed. We see things starting to move from Poland and then starting to pick up in France and Belgium as time flows. So there's an example where we're taking our time bar and using it alongside other components to help pass data back and forth and allow the user to visualize the pieces and answer a holistic question about what's going on. And then the last thing I'll show you here, before I hand it off to Louis, is an example where we may want to apply that filtering by time, but also look at subsets of the data. So as I mentioned, it's not always the most relevant to create a KeyLines chart with all of the data that you're looking at. You may want to look at individual pieces in isolation, but you may want to look at those pieces over time and how they're all connected. So for example here, we may want to focus, we see a big spike in the second week of September, so let's zoom in on that area. And we're going to filter the chart so that we're only looking at traffic that took place in that third week in September. And you can watch the traffic, in this case, the items that are in the foreground are the items that fall into the time range that I have selected. Let's go all the way down to individual minutes of the day, individual seconds, and look at specific items. Let's perhaps animate that too and watch how they change over time. Where are things flowing? Which things are appearing and disappearing off the chart as we change the time window that we're inspecting? And then the other piece we may want to do is look at individual subsets of this data. For example, this individual's traffic. What's happening with the traffic originating from that specific IP address over time, and look at those patterns and contrast those with the patterns over the entire data set that we have. So we can see if there's something anomalous. For example, this person that I pick in orange here, we can see that they had a spike in activity in the beginning of September, but then dropped off, in fact, to zero. That nobody was using that particular device after the first month. Whereas in contrast, this person that we have selected in green had a relatively steady state level of activity until the very end of the time period that we're looking at. So as I mentioned, I am more of a visualization expert than I am a cybersecurity expert by any stretch. So what I'm going to do now is I'm going to hand it over to Louis, who's going to spend a bit more time talking about his application and how he uses KeyLines to create a cybersecurity application for his users. And then we'll switch back to me at the very end and take some time to address your questions. Thanks very much. 1 second while I hand this over to Louis.
Thanks, Corey. Can you all see my screen now?
Yes.
I assume so. Okay, thanks. So my name is Louis Gasparini. I'm CTO over here at Cyberflow Analytics. We're about 1.5 years old, based out of San Diego. However, I live in the San Francisco Bay Area. Cyberflow Analytics, hold on, yes. Cyberflow Analytics has created anomaly detection solutions that looks at network traffic in order to find something that's just not normal, not normally seen inside the network, and potentially an adversarial threat. There's a lot of activities we all know in the network, and network security, and smart buildings, smart factories, and smart cities. And in order to look at all that traffic, we need some kind of continuous threat monitoring to look for policy violations, security, operational security anomalies, and advanced security threats. It is difficult to take so much data and deal with it in big data in trying to crunch it after the fact and looking for a needle in the haystack. What we've done at Cyberflow is that we've taken it in real time and taken a streaming approach. We will look at the data as it comes through and score it in real time for a potential anomaly or threat. Once that event is scored, depending upon the score, we'll then send it to our visualization center, which is using KeyLines and helps us to look at just the most interesting events. So it actually gives us a layer of filtering away from all network activity, which could really, as Corey's pointed out quite nicely, could really flood a visualization display. We do this through monitoring. As I said, we monitor the network. We put a probe on the network in various locations and monitor all network packets. We summarize those packets for 10-minute intervals and the activity of communication between IP addresses during those intervals. We then machine learn what normal activity is between machines. I'll get in a little more detail about this in a minute. And then we do our scoring in what we call a term that we've coined anomalytics. And we do analytics to look for anomalous events. And then based upon the potential threat that might be associated with that, we'll raise a risk score and raise it to our security ops dashboard. Let me talk a little bit as an example about how we do what we do. We all know of Target from last year, very well known. How did that occur? Target was PCI DSS compliant at the time of the breach. Fazio Mechanical, the vendor that got compromised, was in full compliance with their industry practices. They all had firewalls, SIMs, antivirus, IPS, and compliance across the board. But still it occurred. How did that occur? What was missed? Well, what was missed was a variety of abnormal things. Abnormal communications with a partner. That never occurred before. Internal pivoting and data movement that was occurring within the network and nobody noticed. Access to POS terminals from machines that never spoke to those terminals before. Linking all of these events together and correlating them and showing them, even visually, what the links are between these anomalous and not normally seen and potentially malicious events. Data transfer from POS terminals to a central staging area, and an FTP from a DMZ server to an external internet server controlled by the perpetrator. That FTP server was normally used for inbound traffic. Well, then all of a sudden it was used for outbound. Nobody noticed that change in direction, that data volume flow in that change of direction there. So we've created a product what we call Flowscape, Internal Threat Detection. Let me give a little example, sort of a recap of what I just outlined for Target, in a sense, of how this would work. So an actor a malicious actor gains access to a partner network. And then all of a sudden, they're speaking to a machine that they've never spoken to before. This should have raised an alert. This should have sent an event to the dashboard. In Corey's graphs, you can visualize, and I'll show you in a minute, a single line between two nodes. Those two nodes with an uncertain event that occurred. And then from that event, you see him probing around and looking for another machine, which an actor moves to. That would add a third node to the graph. Then from there, they go to find an admin machine that has privileges to get to the data servers. Would add another node to the graph. Go to the data servers to get some data. Communicate home to command and control. Again, all these low-level events that are going under the radar scope that they're not catching. As we all know in security, there's many events that flood the network, and it's hard to correlate these things together. Well, the correlation of them together and tying together these events is key. And then they move to an FTP server and start moving, the crown jewels over to there, and then out the door. So these are the things that are getting unnoticed as single individual events. Bringing them together is what's necessary. So how do we do this? What we do is we use analytics and a detailed bookkeeping of who speaks to who on the network. We learn what the normal communication patterns are on a network of who's speaking to who, over what port, what time of day, how much volume, etc. We then look for anomalous activity. You see two machines speaking that have never spoken before. Okay, in and of itself, who knows? Could be a new application, could be a new friendship made in peer-to-peer talking, could be a lot of things. But let's put both of those machines on a watch list. We then will inspect them even deeper. We'll turn on full deep packet inspection and look for markers and other indicators of fraud, of potential malicious activity. Then one of the machines speaks to another machine it's not spoken to before over a port that it's never used before. We'll add that one to our watch list and our node list of linked nodes in this activity to track. Then that machine speaks to a critical guarded data server. Well, by this point, the alarm on the cluster of activity is raising to a higher value, which the security ops persons can then drill into more detail and stop the event before it gets too dangerous. Very quick recap. I already mentioned this earlier. We put network sensors at various locations on the network. 10 gigabit Ethernet connection, TAP or SPAN port were available as an appliance or a VM image. Here's a good example. It's a not cluttered example. This is more of the pure example of the kind of activities that occur over time. These events are what I would call, interested events or ticketed events. So you can see number one, the internal reconnaissance between the two nodes. Then number two, remote control out to another node. These occurred over time. I actually don't have a live dashboard to show right now, but if I hovered over on the events or on the links between them, I would get more information. On the links, I would get the time of the event, what kind of event it was, what port was used. The nodes would show the IP addresses. And you would see in this particular case, this could be over hours, days, or even weeks that this slowly grew. This, what we call a cluster of activity. The first time it might be, who knows, uncertain. But then as more and more events link to this, depending upon the evaluated severity risk of that event, the whole cluster grows. Once it hits a certain risk level, it becomes what we call a case, and then that is when it's highlighted to the dashboard. We also have, as you can see on the top there, a replay button up on top, which is very nice. Again, I can't show it because this is just a PowerPoint screen, but if I hit the replay, everything would disappear. Just the first two nodes would appear, number one, and then number two would add 3 and 4, and then you can get sort of a visual representation of how this thing played out over time. Looking at the various models, our mathematical expert, Dr. William Wright, likes to talk about binocular vision and stereoscopic vision, where essentially he's taking the various models, fusing them together, and coming up with an overall score in order to lower false positives and just raise only the most interesting events. So the way we do this is if any of you are into modeling, there's primarily two ways of training models. One is supervised training, which I come from the banking industry a while back, and very popular in fraud and money theft, where you train the model. You say, here is examples of bad activity, and you give it a whole bunch of activity, and you mark the bad activity. So you've got marked data. You train it as to what is bad. It learns what is bad, and then as new activity comes in and scores it quite well. It works actually very efficiently. I've used it in the past and very happy with it. And then there's unsupervised learning, which is what we're using here right now, because we don't know what bad activity is yet. We're just looking for anomalies. This is different. So in unsupervised learning, you can see on the bottom two slides, those clusters of activities. Those would be like activities that normally show within the data. And on the right, you'll see where the centroid nodes were created that sort of link to the cluster areas. One node in the sort of center with the red circle around it, clearly stands out. It's not part of any cluster of activity. That would get a high anomaly score. So we use unsupervised training and SOMs, which are self-organizing maps, in order to baseline what normal activity looks like and identify abnormal activity. Let's talk briefly about a case study, then we'll get into some visualization views. This is a customer that we currently have. This is called a data center with 1,200 networks, devices, 12,000 workstations, 1,000 servers, 500 printers, quite a bit of activity going on in this network. This customer spends about $600 a month, it is, I think, on infected devices. And Flowscape was able to reduce detection recovery by 50%, saving an estimated $260,000 a year. So great benefit to them right out the door. So what do we see when we turn our system on? And now you're seeing some keyline graphs here, finally. Corey had done a great job of showing how that works. And it is a very good product. We use a combination of KeyLines and Neo4j in order to display and track and mine our data. On day one, when we turn it on, because we do, our system has a combination of things. At one level, it requires a little bit of learning of what normal activity looks like. So on day one, you can see we have we paint the network. Here's who's speaking to who. We learn what's going on with what, and on the dashboard, if you were to pay attention to that, you'd see a lot of activity like you do here. After a few days, we clear out the dashboard, and then we get to a steady state, and that's when it gets interesting. You can see on the middle one, events, we've got fireworks here that's going off. These are very interesting. We'll talk more about this in a minute, but we're seeing stuff that not a lot of the other security vendors are seeing because they're not looking at it this way. They're not looking at who's speaking to who over time and painting that. And then in the steady state, now we're getting to just the true anomaly things that are worth investigating and looking at in more detail. So here on this next slide, the same vendor, you can see on the left a whole bunch of NetBIOS traffic that's being mapped out. This is more sort of earlier state-ish. DNS servers on the bottom, SNMP servers, the star there in the blue in the sort of middle right, backup servers, other IoT server applications. Now here is where we started picking up very quickly. This stood out like a needle in a haystack. The color coding, by the way, is our risk score severity. So a blue would be medium to low risk. We don't low to not much risk. We don't even show it all. So like I said earlier, there's a lot of noise that we keep out that way. So blue is sort of medium to low. Orange is sort of medium to high, and red is high. In this case, you can see that we're detecting a BitTorrent traffic that was not normally found on this network. And the folks at the network were so happy to see this. They didn't know what was going on. They wanted to stop it, and this gave them immediate visualization into that. On this one is a combination of things. I'm sorry if it's a little hard to read. Here we're seeing a botnet command and control activity with this Saudi botnet, which was really a home device that was compromised for this enterprise, and then they VPN'd into the network, and then we detected the activity of the home device going through the VPN and looking around internally, and we were able to raise that quickly to the dashboard. And they were able to shut that down and stop it from spreading internally within their network pretty quickly. And here is an example of a breach from Croatia, malware Metasploit that was coming in and doing remote control. I'm seeing a bunch of questions about audio being gone. So hopefully you guys are hearing me. I don't know. Corey, can you hear me?
It was gone for about 2 minutes, but it's back.
Oh gosh. Okay. All right. Don't know what was missing. Great. And so here is some activity from Croatia that was coming in. You can see on the top left graph, there are the two red dots there are the ones of interest. So as you can see, this would be the dashboard of all the strange events that are going on, and then the ones that are just the red and the orange sort of just stand out, that you can just research those only. And when there's so much activity and so much going on, it makes it so much easier to be able to just focus in on the highly anomalous and potentially dangerous events. So that's pretty much what I have. So I think I'll turn it back over to Corey, and then we can go into question and answer. Corey, it's all yours.
Thank you, Louis. Yes, so I'll just go through some of the questions here and just pass along to Louis the ones that are for him. So the first one is for him. It says this person's curious to get Louis' take on how Flowscape's unsupervised learning copes with persistent attacks that were perhaps already in progress at the time of the Flowscape deployment.
Yeah, well, we use a combination. I said we benefit greatly from being able to learn, have a learning period, but we also do things out of the bat, out of the door day one. We also, so for example, Model 111 I mentioned that identifies subvert communications through protocol usage. That one would work right away. We have the ability to look for certain things that we would mark as a higher score right away. Also, even in the learning, if it's not used heavily, it sort of does stand out anyway. It would be visually, it would raise to a high risk score. So it does have a combination of both of those in place.
Great, thank you. The next one's for you as well. Somebody asks if Flowscape uses only its own sensors as data sources, or can it incorporate third-party data sources, connection logs, or web proxies, firewalls, things like that?
Yes, that's a great question. We're currently in the middle of doing that right now. It is not complete yet, but that is a feature that we are quickly adding to the product.
Great, and I think the subsequent ones are for me here. Somebody asks basically how to develop applications on top of the platforms discussed. So I'm guessing that's for KeyLines, and basically because it's a JavaScript component, we try to remain completely agnostic as to the type of web application that you're writing and even to the data source. So as long as there's some mechanism of getting data into KeyLines via passing it from the server down to the client and getting it into JSON, which is the format that KeyLines accepts, then it doesn't really matter how the application itself is hosted or where it came from. Another one asks, do we support ontologies, especially OWL and RDF? So we do. This sort of fits into my previous answer as well, in that as long as there's some way to convert that data into JSON, into a node entity property or a node link property type format, that it doesn't really matter where it came from. And we do have plenty of customers who are using them on top of RDF type sources. Another question is, how important is styling to communicating cybersecurity insight? And I think the answer really is, it depends on the level of sophistication of your user. So if you have users who are very used to working with this kind of data, know exactly what it is that they're looking at, and can take action based on the patterns that they see, then styling may be less important than if you're relying on a less sophisticated user where you need to really convey visually more information about the type of data that they're looking at. So while using, for example, node icons, sizes, colors, that can really help if somebody already knows that type of data and would benefit more from seeing that those things in a tabular format, perhaps elsewhere on the page outside of KeyLines, then you may not have to pay quite as much attention to the styling. But being that it's an important aspect of KeyLines, I am going to say it's quite important no matter what your data source is. And then the final question I have here, actually a few more came in. So the last question previous that I'm looking at now is, are there any layouts that are particularly useful with cybersecurity data? And I think the answer is no. We offer in KeyLines a number of different layouts that are unique to the type of data and the connections in the data that you're looking at. So the hierarchical data, the hierarchical layout can be really useful if the data that you're working with has a tree type structure. And there are certainly views when looking at cybersecurity type data where it is organized in a tree type structure, so it can be useful. But there are other types of data where a hierarchy would just confuse things because it's not organized that way. So I don't think that any layouts are more important than any others in this domain. Okay, here's another one for Louis. You had mentioned banking and target. Are there different visualizations or things that are more likely to be seen or desired in different industries or different verticals? So for example, does finance or retail have different visualization needs?
Right, yes. For what we're doing at Flowscape, I would say not dramatically much different, because we're looking at internal reconnaissance and machines trying to do malicious things. And so the visualization pretty much stays the same for the industries, because it's more of internal actors on your network doing things they're not supposed to be doing. However, from my banking days, and the great example, Corey, you showed earlier, is sort of the link analysis. Where's the money flowing to? Where is the money flowing from? Looking at money flow between accounts, for example. And when I was in banking, you would see if you would track, where these transfers are going to, and all of a sudden you see a large amount of transfers going to the same account number, or activity from there bouncing around to other account numbers. Linking that analysis through is very, very powerful in the financial industry. So I would see where it'd be beneficial. At Flowscape, we're looking at something different. So if we would stay more with the network visualization.
Okay, the next question also for Louis is, does Cyberflow track each node or host's identity profile as part of its analytics? So for example, does it know that a node is a DNS server, a web server, a thermostat, an Android device, etc.? And is that important, or is the connection activity itself considered to tell the whole story about that device's activity?
That's a great question, and right now we're not tracking it specifically, but it's another thing that we are looking to add, is being able to say, yeah, this is normally, well, actually, in a sense, we are doing this, because we say that this machine is normally a server of this type. So if it's a DNS server, then it starts doing other things that a DNS server doesn't normally do, then we would catch that. But we are looking to add more identification of the machines and being able to, even up front, and this would help us at day zero, identify, this is a workstation, this is a database server, this is a DNS server. It shouldn't be on other things, even without having to learn over a week or so what that is. So yes, that is something that we quasi-do today, and we're adding more features to do that even better as we move forward.
Okay, the next question is, can we use this technology on the cloud, or is it just desktop? So I'll answer that for KeyLines. It is a web-based component, so it runs within the browser. We have plenty of customers who have built solutions using KeyLines and deployed it on the cloud on AWS or something like that. That's perfectly supported. You download the JavaScript and use it in your own environment on your own application. We don't host anything for you, though, so that would all be done by you.
And for Cyberflow, we do offer a solution where we're collecting the data, which must be on the network wire. So the collector must be, of course, within the enterprise. That could be then sending summarized data up to our analytics server in the cloud, and then the visualization with KeyLines and our dashboard is all from a web browser from the cloud.
Okay, and I think the last question I have here is, are you doing or have you done work in a distinctly sequential domain, so not necessarily temporal, for example, with supply chains? And I'll answer that. We do have some customers who have been interested in building supply chain type applications and looking at how KeyLines might help visualize connections between suppliers, the products that they supply, and things like that. I don't think off the top of my head anybody's built a production application for that using KeyLines yet, but we have had a number of people evaluate it and are currently in that process of building it. Okay, I think
Corey,
that's all the questions I've got.
I think you missed one, actually. Or maybe you answered, I didn't catch it. Is it possible to enforce a specific structure?
Oh, you're right, I did miss that one. Thank you. So the way KeyLines works is there are a number of automated layouts that you can run, but there's also a manual XY coordinate associated with each node. So if you want to build a structure of nodes, put things on opposite sides of the screen and things like that, that can be done either manually by the user dragging items around with their mouse, or imposed in the code itself by changing the coordinates of those nodes. And actually, while I was answering that, another one just came in here. So can we automatically generate links in our list data? I'm not sure who that's for. So I suppose I'll answer it first in that KeyLines can dynamically add new data to the chart in real time as things change elsewhere. So you could easily have new links being generated because they got added to your data source and fed down to the user who is currently logged in and has KeyLines up and running. That's no problem.
And we do that. We that's one of the best features of the product is that, you know, as new events show up, they automatically just show up on the screen.
All right. Well, thanks very much, everybody, for attending. We do apologize. We had about 90 seconds where the audio had cut out for everybody, so I couldn't even come on to tell you that we were working on it. But it did come back, so we didn't lose that much, and we do have a recording of both the slides and the audio from this. So if you want to hear the riveting things that happened during those 90 seconds, we'll send out the link to that, and you can take a look yourself. All right. Thank you very much, and have a great day, everybody.
Thank you, Corey.